Last time we found the inverse of this 2 by 2 matrix, 1, 1, 1, 2. How we found that inverse is we created this matrix A, B, C, D, multiplied it by this 1, 1, 1, 2, and set it equal to the 2 by 2 identity matrix. Because if we have an inverse, then the matrix times its inverse is going to give us the identity. So what we did was we multiplied these two matrices to get this one here. And then since we want these matrices to be equal, we see that A plus C is 1, A plus 2C is 0, and so on. So we got a system of two linear equations with two unknowns involving A and C, and then we got another system involving B and D. And from those systems you can find A and C and B and D. And we find that for the matrix A, which is 1, 1, 1, 2, we have an inverse, which is 2, -1, -1, 1. So that was the inverse of a 2 by 2 matrix. What if we want to find the inverse of a bigger matrix, like a 3 by 3 matrix or a 4 by 4 matrix? Look at this matrix here. I'm going to call it A, and it's a 3 by 3 matrix. Well, we could do exactly what I did for the last problem. We could come up with a matrix B, and let's say it's A, B, C, D, E, F, G, H, I. I want it to be the same size as A, and what I want to happen is A times B. I want this to be the 3 by 3 identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And then I need to figure out relationships between A, B, C, and D, E, F, G, H, I to find these values. So what are my relationships, and how can I actually find all of these letters? And is this matrix even invertible? If it's not invertible, then there will be some kind of error. There will be something that just doesn't work out. So I went ahead and started this for you using this method. You see that I took the matrix A and I multiplied it by this matrix B and set it equal to the identity. And then I multiplied the left-hand side of this equation. And when you do that, you're going to get three systems of three linear equations and three unknowns. You can see you're going to have more work to do. You're going to have to figure out A, D, and G. And you can set this up like we did in the very first section. I think it was section 1.1, where we can make a matrix, an augmented matrix, and put it in reduced row echelon form to find the solutions for A, D, and G. But we'll have to do it 3 times. And that's going to be a lot of work. And think about it. If we have a bigger matrix, if it's 4 by 4, then we might have 4 systems that we have to solve, and so on. So maybe there's an easier way to find the inverse. Now this is a perfect way of doing it. It's just going to take a long time. So that's what we're going to learn in this section. We're going to learn how to find the inverse as quickly as possible. It might take some time, but it's going to be a lot easier than this. And to do that, we're going to have to learn some definitions first. We're going to have to talk about elementary matrices and two matrices being row equivalent. Once we learn this, we're going to find the inverse of something in a kind of a hard way, and then we're going to put it all together and learn how to find the inverse really quick.